So here we have Newton's second law. The sum of the forces equal mass times acceleration. Acceleration is a vector, so that means forces are a vector. And the acceleration is always in the same direction as the force. In same direction. That also means that you have the sum of the forces in the x direction equal the acceleration, or mass times acceleration in the x direction, and the sum of the forces in the y direction equal the mass times the acceleration in the y direction. Oh, well, let's take a look. So, I'm in a boat. You betcha. And I'm rowing in this boat, and I'm rowing in this direction, so the force of my rowing in this direction is 17 newtons. However, old man Winter comes up, and he decides to blow some wind at me, and now the wind is breaking off in this direction at 15 newtons at an angle of 67 degrees. So now, I want to know what is my acceleration in the x direction and my acceleration in the y direction. Ooh, I need to know the mass of my boat. It's 1,300 kilograms. I need to know a positive direction. Positive x is this way, positive y is that way. Alright, let's get to it. So now, the sum of my forces in the x direction. Move the camera a little bit. Sum of my forces in the x direction are going to give me my mass times the acceleration in the x direction. In the x direction I have 17 newtons in the positive direction, and then I have this part of the wind, the force of the wind in the x direction. So that's going to be 15 newtons times the cosine of theta. 15 newtons times the cosine of 67 degrees, which turns out to be about 6 newtons. So that gives me 23 newtons in the x direction. What about the sum of the forces in the y direction? That's going to give me my mass times my acceleration in the y direction. So what do I have? I have nothing in this way, but I have this part, which is going to be the force of the wind in the y direction, which is 15 sine theta. So this is going to be plus 15 sine 67 degrees. So plus n 0 due to the boat. So now what do I got? I have 15 sine theta, which is 14 newtons. Now, I need to find out what the acceleration is. So 23 newtons equals 1,300 times the acceleration in the x direction. My acceleration in the x direction is 0.018 meters per second squared. The acceleration in the y direction is 14 newtons equals 1,300 acceleration in the y direction. Acceleration in the y direction is 0.011 meters per second squared in the positive direction. But now, let's say I actually have some sort of initial velocity here. I actually started out moving at plus 1 meters per second. So the question now becomes, got a little goobers on the bottom there. The question now becomes, the initial velocity of my boat was 0.15 meters per second in the x direction. I had no velocity in the y direction because I was just moving there. Now the question is, after 65 seconds, how far did I go? Did I move? Well, if we look back at my boat, I'm starting here. I have the wind pushing me this way and me rowing this way, so I'm going to have some final velocity in some direction. let's figure out how far I go in the x direction and how far I go in the y direction. So, in the x direction, so the question is, how far do I move? I'm going to move some distance in the x direction and some distance in the y direction, and this is going to give me my final displacement. Let's find out what r is. So, r is going to be the square root of x squared plus y squared. I need to find out what x and y is. So in the x direction, x final equals x initial plus v naught in the x direction times t plus 1/2 the acceleration in the x direction, t squared. X final is what I'm looking for, because so x final, I'm starting out at 0. My v initial in the x direction, let's go back and check. My v initial in the x direction, it's right there. 0.15 meters per second after 65 seconds, plus 1/2 my acceleration in the x direction, which is 0.018. 0.018 times 65 squared. When I do all that math, I get blah, 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 48 meters. In the y direction, somebody may want to double check me on that one. Let's keep going. Y final equals y initial plus v naught in the y direction, t plus 1/2 the acceleration in the y direction, t squared. 0 plus v naught in the y direction. My initial speed in the y direction is 0. Yes, I love 0. Plus 1/2 my acceleration in the y direction, which is 0.011. Is that right? Yes. Times t squared, 65 squared. This ends up giving me 23 meters. So now I'm trying to find out what my resultant is. It's going to be the square root of 48 squared plus 23 squared, which gives me 53.2 meters.